Cool. Lately I go by the title of founder, but that doesn't really say anything. I've been a technical Agile coach for a couple of years, and that's what I am really in my heart. So that's what this talk is about. I'm talking a little bit fast. I'll try to figure out the right speed for this. I call myself a coach because I love working with people and with humans, and I'm very human-centric in my approach to code and to refactoring and to software quality. Agile is in the title, obviously, because I like the Agile Manifesto. And technical part is the thing most people overhear and think I'm just an Agile coach. I'm not at all like an Agile coach, because technical Agile coaches concern themselves with specifically this principle from the Agile Manifesto that says that continuous attention to technical excellence and good design enhances agility, right? So it's technical excellence. It's about all of these practices, right? Test automation, clean code, pair programming, software architecture, and branching strategies, and all this really nitty-gritty stuff that's super. I think is the most fun part of tech, building cool pipelines and stuff like that. In this talk, I want to tell you a story from my own life. My second experience as a tech lead, and it started as most stories from a previous consultant with a new project. Right, that's where I came to somewhere new, and everything was chaos, as it usually was. So it was an unknown technology that I'd never worked with before. It was a huge code base, very scary, right? Nobody knew all of it. It was constantly breaking in all these weird sorts of ways. And we also had a legendary bus factor. There was only one person on the team who could deploy this code. It was just amazing, right? It was a manual process, so only one person could do it. We had a bunch of tests, surprisingly. Unfortunately, they were all red. And the architecture was a jumbled mess. We were the third consultancy to get this code base, and whenever a new consultancy gets a code base, they're like, the previous one is bad. We're going to redo it, and this time it's going to be better. And then they get like 1/3 finished with it, and they never get around to the rest of the stuff. So it was sort of like this, it didn't make any sense. And anytime we had to go and make some changes to it, we'd be like, I really don't want to touch that part of the code, right? It's all of the parts are bad. We can't really do anything with this. I was put on this project. I was put there as a developer with no special powers whatsoever. I was just like all of the other consultants on the project. But what made me different was that I had a vision. I had an idea. I wanted to make this team the team that all the other people wanted to be on, all the other consultants, right? I just wanted to make the best experience for everyone. Because I figured if this was a team that you wanted to fight to be on, then probably I'll get the best consultants, right, on this project. I've later learned that it's not about the best consultants. It's more about feeling psychologically safe. But that was a side effect of this anyway, so that works still. I asked the team if I could, if they wanted to take a chance on this idea I had, and they agreed to humor me. They were like, "Okay, fine, Christian. Here is the keys to the kingdom. Do your worst." And now it got fun, right? The first thing I did was get rid of all of the dead weight that we had. So that meant I deleted all of the comments and all of the red tests. Gone. We're just wasting time on those anyway. Trying to understand them would take longer than just writing new stuff, right? Especially out-commented code. It had a bunch of out-commented code. I don't understand why people do it. Git is invented, right? You don't need out-commented code. So delete all of that stuff. Second step was we had a huge issue with the customers calling the consultants to get a demo of something, some feature or whatever, and then they would say, "Oh, that's fine. Also we need, and also we need, and also could you change this thing?" And so they would make all these extra requests. So I said, from now on, no more. You can't talk to the developers directly. I have to be present at all meetings that the customer is at, and then I would stop them at any time they tried to make new suggestions and stuff like that. Because then I would take all of that waste upon myself, but at least I would know how much waste was in this process currently. I also did a bit of a controversial action. I took out the bus factor and said, "You're not on the team anymore." And it's because the person had a tendency of making himself a bus factor, right? If it was something that happened incidentally, that would be fine, we could fix that. But this guy was like, he was sort of proud that he was the only one who could do this. He was sort of special and stuff. And while I understand why he wanted to feel that, it's too dangerous for the team. And so what I said is, from now on, you can't touch the keyboard anymore. All of your ideas have to go through somebody else's hands, right? So Llewellyn Falco calls this strong style pairing, which is super awesome, right? From head into code, an idea must go through someone else's hands. So that way we got all of the knowledge that he had transferred into someone else before he left. And then, he was out of the door. Good. That was the waste part. Then I figured, okay, what's the biggest problem with this project? Why is it always burning? Well, I figured it's because we're missing safety, right? The code quality is low, so people are scared of changing anything. And I wanted to bring that up. And being mad with power, I almost want to say, I just said, okay, from now on, all new code has to be tested. Boom, I've said it. So obviously that happened, except nothing happened, actually. It turns out you can't just tell people that now they should test their code and then they'll do it, because they're in the same context. Everything's still the same. And the code is like really, it's not necessarily easy to start testing code. That might be a very big upfront investment. In fact, we had this silly situation where I had just said, all the new code needs to be tested, and stop saying that you're done with stuff. If it's not tested, I don't want to look at it, and the customer can't look at it either. And 2 days after, the customer calls me and says, hey, we have this release on Thursday in 2 more days. Are we going to be ready? Do we have this feature? Is that included in the release? And I look over at the developer and says, hey, can this release be, or can this feature be ready for the release? And he said, yes, if I skip testing. And I'm like, no. Then you say no. It can't be ready. We just talked about it, right? But the problem is that to do testing, you need refactoring, but you also need, to do refactoring, you need testing. And so you sort of have an infinite loop there. It's very hard to get started with. So then I figured, okay, then maybe the code is the problem. Maybe that's where we should look. And so I had already studied a lot with code quality and stuff. So I decided to, every 2 weeks, I would introduce a new code smell that we would work with for 2 weeks. And then I figured that smell would be out of the code base, and then we'd move on. Nothing happened. Because, well, code smells aren't immediately easy to apply either. Whenever people were about to refactor the code, or supposed to be refactoring the code, they would sit down and they'd start reading it, right? And in a bad code base, it takes forever to read stuff, right? It's just, and it gets worse the worse the code is, and the more it needs refactoring, and then you're back in another infinite loop where you can never actually improve anything, which was super annoying. So then I figured maybe it's the environment, right? I just started hearing, back then, it's a while ago now, I just started hearing about this guy called Woody Sewell, and he had this awesome saying. He said, the object is not to create great software, but to create an environment where great software is inevitable. And I was like, that sounds like the key. He has solved software development. And so I introduced a concept that I've also since then introduced in many places, because it is actually hugely beneficial. We call it Improvement Monday. I would give the developers just time to work on whatever they wanted. And the thing is, developers are super creative, right? They're really, really brilliant people. And if there is a problem, they'll solve it themselves if they're allowed to, right? If you create like an environment where they're super busy and they don't have time to fix anything, of course they won't solve anything because they'll try to do what they're supposed to. But if you let them, they'll solve all their own problems, I figured. And so the way that we do this is we have every Monday we set aside something like this, where we start the day with a pitch and recruit. Everybody says something that they've thought about working on, something that annoys them. That class that was bad last week, a process they've discovered, something like that. Everybody pitches their idea for what you could work on. And then the recruitment part is everybody also goes together and works on the same tickets, or decides which tickets they want to work on. And so we pick, in this case, it's just document the process and refactor the code. Then the next step is to define a goal. You have to define something that you can do that day, something you can finish, right? And refactor the code is too general. You can't. That's not a thing you can say that you're done with. But refactor class the Java is more specific, and it's something that you can actually do. And then we have the focus time, the big block up here, where we use something called mob programming, or Ensamble programming, as it's more known now. Where we have one big screen and one keyboard. That's sort of the premise. And then we have a guy at the keyboard. He's called the driver, who is the person. We're using a version of Lowell and Falco's strong style pairing again. So he's at the keyboard. Another person is the programmer, or the navigator, decides what's supposed to be done. And the driver can only do what the navigator tells them to. Nothing else, which is the hard part, because we have such a strong tendency to like scroll a little bit up and down, check something. Oh, I saw a spelling mistake. I'll just fix it. Don't. Right? You only do what the navigator tells you to. And then finally, we have what gives name to the method, the Ensamble. The extra brains that help you keep track of all the things that are going on right now and all the other parts of the code. Because when we're coding, we need to have a model of the code in our head, and these extra brains can really help with that. Especially if the team is cross-functional and have slightly different specialization. And then we switch every 3 to 6 minutes, and that sounds immediately insane if you've never tried it. But it turns out that 3 minutes isn't actually that bad, because also you're not stuck for very long, right? You're always moving on to the next person. And then we just rotate. Teams who are more mature with this method can use longer periods, like 15 minutes. I've heard of people doing an hour, but I can't imagine that won't be a lot of context switching in and out. Shorter periods are usually better for this, especially in the beginning. So then after we've done some work, we go to lunch, of course. And then when we're back from lunch, we do a touch base just to check, are we still working on the thing we said we were? Do we need someone to join us or switch the groups around? Is there something that sounds more fun? That's fine. We do all that stuff. And then by the end of the day, after another focus session, we just check off, did we do the thing we said we were? And in the beginning, the answer is no, but over time, people learn to sort of judge how much you can do in a day, and then it's usually yes. And then we do a retro, and I always do them in the style of loved, learned, and lacked. And that's also another way you can hear I'm not an Agile coach, because I only do one type of retro. And it's this one. And these are just some typical tickets that we get every single time I've held this. We get these on the first time. It's nice working together. By the way, it's sad that people need to say this. They should be working together every day, obviously. Somebody learned some new shortcuts. People get really a lot more efficient with their tooling when they see other people from the same team just using the same tools. And then there are too many interruptions. It's very difficult to make time for a whole day of not doing feature work, especially in some organizations where they're very focused on output instead of impact. Good. So I'd introduced Improvement Mondays, and obviously then the code got fixed, right? No, nothing happened. The issue here is that code smells are really difficult to understand in themselves, right? You can't just learn a code smell and then you can sit down and do it, because it's abstract. It's sort of it's based on gut feeling, I like to say. But that's really difficult to transfer to other people what gut feeling is. Like, when is this code good enough? We can sort of argue about it, and especially in a team where people are a bit timid, nobody will want to sit down and say, what is the actual limit? And so it requires practice. You need practice to do refactoring well. That's just how it is. Refactoring is a thing your fingers do, not so much just something that you can do with your brain entirely. Good. So I figured maybe the smells are broken, right? And so I sat down and I again researched all of the smells I could find and all of a bunch of different resources. And then I was like, okay, all of these are too abstract. I need to come up with new rules instead of smells. That sounds already better for me. And I wanted them to have 3 criteria. The first one is they should be easy to remember, because if I add more stuff to people's head, then again I'm doing the exact same mistake of the smells. I can't rely on people thinking, but remembering is sort of okay. They should also be syntactic. That means you can see it by just looking at the code with no brain, right? You just look at the code and you can say, oh, that one's bad, that one's good. So it's cognitive light. Again, we're trying to take things out of the head of the developers because they're already full up. And then they should also be safe to execute, even if you don't understand the code, right? We need to be safe all the time, but I don't want safety to come from a person read it and understood it, because again, that's a thing that's really hard to do. That also means I had a problem with all the existing refactoring patterns, because all of them that I could find rely on testing. So I had to come up with new ones, new tools that don't rely on testing, because, as I said, I deleted all the tests. And they were red anyway, so they wouldn't have helped us. So what are some? I had to think about what are some operations that I can ask my developers to do that are low risk and will still that I can still compose into interesting refactoring patterns. And the first one is copy and paste. If there's something most developers are good at, it's copy and paste. It's also pre-practiced, so that's really good. It's very unlikely that you are going to mess something up by copying it and pasting it, right? That's not when the danger happens. The other thing is doing really small steps. And now that I've used it for a while, I can confidently say this is probably the most dangerous thing that I'm asking people to do, is go slow, because that's so hard to do. Like we want to go fast, right? We want to refactor all this code, and once we think we see the next 5 steps, we try to do them in one, right? I can just do all of these things. But this is where it breaks in practice. It's because people are not patient enough. The final thing that I felt I could rely on was the compiler, and that's because I always work within typed languages, and so the compiler has a type system, and that means it can catch a lot of mistakes at runtime or compile time. Sorry, and it's a super powerful tool, and it can do so many things. And I was like, if I can design these rules in a way or these refactorings in a way that relies on the compiler, so that you know when you're in a green state and in a red state, because the compiler will tell you. That will be super powerful. Also because it is constantly there, right? It's not something we need to maintain over time. It's not like testing where we need to put something in it. It's just, once you put in some types, they're true forever. You never need to change them probably. And something started to happen. Like between these new things, the code base actually started to move. And so let's talk a little bit about how this journey from smells to rules sort of give an example and look at some code and stuff. I know you're here for the code. Good. So if we look back and see, this is an exceptional book, of course, by Martin Fowler, Refactoring. This is the second edition. The first one was also great, where he says, don't have long methods, which is a good piece of advice. I mean, I don't disagree, but also I can't sit down and use this, right? I can't put it into code because I don't know what it means. What is too long? So what I did was I replaced this rule with something like this. 5 lines, boom. If it's more than 5 lines, it's too long. Easy. You can look at some code and you can immediately see, also I count them, of course, in the way that makes sense. I don't count braces and blank lines. But yeah, this 5 lines, easy, I can see that, it's fine. We can do this. There's a little bit of leeway in the concrete rules. There's more description and a little bit more nuance, but in general, this is the part I want people to remember first. And so if we look at how to apply something like this, we can have some code here. This is just a traffic light sort of simulation on a very small scale. Also, if you're not Danish, you need to know that in Denmark, the light switches from red to yellow red, where it's like you can almost drive, and then it becomes green and then yellow again. I think that's maybe only Denmark. But yeah, so this is just a small thing, and it's more than 5 lines of code. It's easy to see. We don't need to think about it. So then we go through a few of the refactoring patterns now. The first one is we replace the switch with an if-else chain, like this. So the code is the same and it's doing the same. It's just we're using this thing instead, because there's also a rule against using switched, obviously. Even Martin Fowler has that one down. Don't use switch ever. Good. So after we've replaced it with the if-else chain, I'll try to go a little bit slow over this code because I know some of you are trying to read it and listen. And it's very unfair of me to just click through it. So now we want to get rid of this enum that we have here. Enums and switches go together, and since switches go out of the code base, so do enums. And so in this case, we want to replace it with classes instead. And the way that we do this, remember I wanted it to be safe. So we start by renaming the enum to something like delete me or something, because now the compiler will tell us everywhere we use that one, which is amazing, right? Now I don't have to think about it. I don't have to be sure if I hit all of them, because the compiler will tell me if I hit all of them. There is the caveat, though, that this doesn't work if you use reflection or third-party libraries that use reflection or don't use reflection, obviously. Cool. So once we've done this, we can start eliminating them. So we take that little small enum up there, and then we make a new class for each of the values. And each of those classes has a method for each of the values. So we sort of do an n squared thing, right? And for the yellow class here, you can see all of the methods return false except is yellow. And I hope that makes sense to everyone. And then down here where I had the equals, I now just have a call to the new is methods. And then everything works the same, right? And the compiler stops complaining. And so everything is good. We're now in a green state, right? So the compiler tells us whether we're in the middle of something or whether we're in a safe space. So next step is to take this code that we have here that still has ifs and elses and stuff, and there's another rule saying you can't have else. Again, easy to see. There's an else, boom. I know this is bad. Cool. So if we can't have else, the thing is we need to push this code into the classes. So we start by copying it and giving it a new name in the interface. Because when we put it in an interface with the wrong name, the compiler will tell us that all of the classes now don't comply with the thing, right? And we've just pasted in the code. We've removed function because that's just some syntax. We've also replaced the light parameter with this because we are now inside of a light. Right, cool. And so we can now go through these pieces of code here. Yellow still doesn't compile, as you can see, it's red up there. And then we can inline all of the constant methods. The methods that only return a constant, we might as well just put the constant. This one is weird. Here, so it's false in these two cases. And then the next step, as you might imagine, is to just remove all of the stuff that isn't executed anymore. And once we've done that, we can also put in the naming thing that now signals we are done with this method, and the class starts compiling again, right? So once we've gone through all of the classes, we'll know that the code base compiles. So again, when the compiler is happy, we're in a green state. We're in a safe space. Cool. Next, we can take all of these. Yeah, so because we put this temporary suffix on the name, we obviously need to go back and just rename that away. You can either do that just using a refactoring tool, like your editor will usually do that for you. Or again, if you want to rely only on your own two hands and compiler, you can just remove it from the interface, and again, you'll get errors everywhere you use it, and you can do it safely like that too. Cool. Over time, these methods, or not over time, in this case immediately, but over time these will become unused, right? Because the if disappeared, and the ifs were the only thing that were using these methods. And since there are no more ifs in the code, these ones also just disappear, which is nice, because it feels like we've added a lot of boilerplate. And usually the first step in refactoring an enum away like this is you explode the code up to be like 10 times as long, which feels counterintuitive, but then after a short while, it just is flushed out again automatically, which is super nice. Yeah, so over time, let's say that we actually needed some of these. We have some other methods we've introduced. These are not the same as before, because these are controls for an actual traffic light or something like that, where you can see that both yellow and yellow-red has the yellow light turned on, but yellow-red obviously also has the red light turned on. And so in that case, we might want to say, we've split it up too much. I like these two to be one class, right? I just want one class representing these two, and we can discuss whether that philosophically makes sense. But for the in the interest of showing you some cool refactorings, we're gonna unify them, as it's called. So the first step is that we need to figure out what is the basis. What are a collection of constant methods that uniquely identify each of the classes that we wanna unify. In this case, we can pick, for instance, the red light, right? Is red light on is a good identifier for which of these two we're in. And so then we put in an if in each of the methods that just says, well, in this one, it has to be on, and in the other one, it has to be off. So we've inlined if true, or we've added if true, which should be fine. It's still legal. It does the same thing. It's just a bit boilerplatey. But then the next step is to take that code and then add it to the body of the other one. Right? So the not red light cast up goes up there, and the other one goes down here. So we've just crossed it. I think of this sort of in the same way that we divide fractions, right? You just cross them over, if that's something you think about often. Yeah, so we just crossed them, and we now have, these two are now entirely identical, which means that we can just, in the else case, it's either do the thing or the other thing, so we can simplify it a little bit. We don't need the if down on the second one. But yes, now these methods are identical, so the only place that disagrees is the constant method. And so instead of having that constant method there, we now take a parameter, and in TypeScript that looks a little bit funky, because we can do an immediate initialization of a private variable, a field variable, with a parameter by just putting private up there. But it just means we have a field variable, and then we're using that instead. That should hopefully also be fine. And once we've done that to the two classes, these two are entirely identical now, right? Whereas before they were sort of similar, now they're entirely identical, and so we can just remove one of them. In this case, we just keep the yellow one. Good, cool. What do we want to do here? Yeah, oh yeah, and now if we look back into the yellow one, we're sort of back where we were earlier, right? Where we started. We now have a type code again because Booleans are another example of type codes, just like enums are. And so we can go through the entire process again. And this is like sort of a flow that once you work with refactoring a lot, you discover that there are these patterns in the meta layer, like patterns of refactoring patterns that you're using. And so I've used this one so many times where we start by extracting some code so that the if is isolated. Then we remove the switch with if else. Then we take the if else with some equals and replace it with the type code thing. And then we use the is methods disappear when we push the code into classes. And then by the end, we inline the method. So there's a common flow that we go through all of the time. So there are a couple of these flows, and and they show up everywhere. Super powerful. Let's talk a little bit about why this is actually interesting, why this code is better, the one we ended with compared to the one we started with, because it might not be immediately obvious. There are two things that make code problematic to work with in an intra-team setting. So for individuals, right, and for teams. The first one is invariance. And my definition is something that the developer knows, but the compiler doesn't know. I haven't told it, right? I'm keeping it secret, basically. It's something like the array.length cannot be negative. I know that, you all know that, but the compiler just sees an integer, and for it can be negative, right? This is a pretty safe invariant, but I'll get back to other invariants in a second. The other thing is coupling, right? Which things are connected to which things? Because when I'm working with some code and I need to make a change, I need to keep track of all of the other things that might be impacted by this change. So the more things that are reused, the harder it is. In my case, I define it as shared by multiple teams, and that's to also further offend people where everybody on a team works as individuals and don't work in sort of an ensemble way. If you're in different flows, I call you different teams, even if you're sitting next to each other. Right? Co-location is not enough to be a team. You need to be in the same flow. It's typical for stuff like utility classes and data classes and stuff that are commonly owned or owned by no one. And it's impossible to change. Cool. So if we look at just a small piece of code, an example here, we have actually evidence of both couplings and invariants in a very small piece of code. And if you were a smaller group, I would sort of ask you and we do like, can you spot what they are and stuff? But I'll just tell you because you're so many people. The first thing we can see is what is the type of ARR, right? Most of you will have a pretty good idea about something that you can't see on the screen, right? Because it is coupled to the implementation. So you can see that this is probably some sort of a numeric array. That would make sense, right? Otherwise, it doesn't compile at least. So we can already see that. So we are coupled to the type of the array. We have also an invariant. We have the one I talked about before, of course, where array.length cannot be, it has to be well defined even here, or it has to be well behaved. There's a great book called Java Puzzlers, where there's a whole section of the book dedicated to looking at loops that look completely normal. And then they say you have to find a way to make it an infinite loop. If you had the power to override this method, you could make this an infinite loop, right? In this case, it'd be fairly easy. You just return float.infinity or something, right? Boom, infinite loop. So it has to be well behaved. That's the first invariant. There's a second invariant though, and that is that this thing doesn't cause overflow. We're not checking for it. So surely the developer has thought about it and figured there's no danger here for the overflow. These are things we need to keep track of while we're coding. There's a final coupling, and I think this is mostly for fun, but you can actually say what language this is even by looking at it. Because at least for me, the only language I know that has the length with a capital L is C#. So it's probably C#, which is also fun, that you can see things. We can contrast that to another way of writing the same piece of code, which would be r.map and then fat arrow +2. In this case, we still have the invariant that this could cause overflow, and we can still see that it's C#, but we've eliminated at least two of the couplings. We can't say anything about what type R is anymore, right? It can be any type. It can be a custom type that implements the right interface. And it also doesn't depend on length. Cool. The reason this is important is that when we're coding in our traffic light example, as here, when we have an enum, we have the dependency point in the wrong direction. We end up distributing our invariants throughout the code base, right? Because I know that these come in a specific order and there are other things I need to keep track of about the data type. And these I need to remember whenever I put my switch in my traffic lights and in my car and in my, whatever that thing is called, where you put your hand. Right? All of these now need to know all of these invariants. And so I distribute them all across the code base, right? They're made non-local. And this is especially bad if we don't have exhaustiveness check, because then when somebody invents a blue color right below the red one, it's going to be very difficult for me to go back and add that and then check that I've remembered to put it in all the places, because I have no mechanism for knowing. Right? Especially if you use default or something like that, it's terrible. Contrast that to the classes where instead everything points towards the data, right? The functionality is right next to the data, and I have to keep track of only what's in the current file that I'm looking at, right? The invariants are localized, they're isolated, so they can't leak out to all these different places, and that makes it way easier to move, to do stuff with, and you can be way more comfortable that you'll either have spotted it with your own eyes or the compiler will catch it. Right? You can still have invariants, you can still have all these bad things, but the scope is a lot smaller than the entire code base. Now they're just this file at least. And then you can make more files, smaller packages, and then you can slowly isolate these out. And as I said, getting back to the story, we did actually make the happiest team. Then there turned out to be a bunch of other problems, but that's a story for another time. It was talked about for a long time as the team that we all missed when it was disbanded, because it was just so fun to work on. You could be productive, right? You could sit down and do your work every day and you felt like you did something, and there was actual improvement. And we started from the absolute worst code base, right? It was notoriously bad. So this was a huge pat on the back for me, and when I decided that I wanted to work more with people than with code, because I find thinking about these things is more impactful, and it made more sense to me to have happy colleagues than to have big bills to the client. That didn't motivate me at all, actually. Okay, if I had to do it again, how would I do it? Because the order is a little bit wrong. As I said, many of the things I tried first didn't actually work. So here are the things that I would actually do now and has done when I go and visit organizations as a digital transformation lead. The first thing is we need technical vision in the team. It has to be embedded. It has to be on all levels, actually. We need it also in management, but we also need it on the team. Somebody has to care about code quality and about the code and about how we do our work and want to make it better. And that turns out to be probably a bigger problem than I initially thought it would be, because I thought everybody was like me and just wanted to do everything as cool as possible. That's not always the case. So we need to have some sort of technical leadership in the team. Second part is we need to have the environment for excellence that I described to you. We need to have a space where we can work together and where we can learn what are each other's strengths and how can we sort of improve and build on upon each other's cool things. So that's pair programming and it's ensemble programming. It is not asynchronous code review, right? Don't do that. I'm sure somebody else is more qualified to talk about that, but that doesn't work for other reasons. Cool. Then remove waste, comments, interruptions, bus factors, all of these things. Get it out, because the longer you have it, you're just postponing a bigger pain when you then have to remove it. Just take it up front, even though it's scary and it hurts. It's an important step and it's necessary. Then we need to prioritize safety. And I think a lot of people think I just mean testing here. I don't mean testing necessarily. Testing is a way to do this, and that's fine if you're good at that, but really just use the tools that you already have, right? If you have someone on the team who's an expert in something, use that. If you have static analyzers, they're so easy to set up, and you get a positive benefit from them immediately. Also, you get 5,000 warnings that you now need to pay off, right? It has its own connotations with it. And localizing invariants. In my experience, this is the most impactful thing to on speed for a code base is how distributed are the invariants, right? How easy is it to move here without being afraid? And then the final thing, reduce the cognitive overhead. And I think that's going to be the currency of the future, is going to be cognitive overhead. How simple can I make this code, and how simple can I make the way of working here? Because when we're solving a problem for a customer or ourselves, we fill up our head and all of our cognitive capacity with the problem and the model and the world, right? developers try to take in the entire part of the world that's relevant for their problem. And if we keep doing that, there is just no space for anything else. And so the more cognitive currency we have, the more productive we can be and the better software we can make. Thank you all very much for listening.